Welcome to this explainer. You know, every single time you double tap a photo or change your profile pic, there is this massively coordinated dance happening right behind the scenes. Today, we're totally tearing down the architecture of a service that handles 5 million photos every single day. We're going to show you exactly how the biggest internet platforms out there, the social networks, the streaming giants, all of them, manage to scale to these crazy heights without just completely melting down. Just imagine your app suddenly goes viral and boom, you hit the big time. You've got to handle 5 million photo uploads in a single day. To put that into perspective, that's roughly 58 uploads every single second, and during peak hours, it can spike to 600 a second. You're talking about generating about 15 terabytes of brand new data daily. And if each of those posts gets just, say, 100 views, you're staring down the barrel of 500 million reads. It's a truly staggering amount of data flowing through your system. Okay, so let's dive right into how we actually handle this. We're going to contrast two totally different approaches. First, you've got the intuitive, but honestly disastrous, naive way, which is routing all 15 terabytes of that data straight through a single API server. Yikes. And then we have the elegant internet scale way. This is where we push data all the way out to the edge of the network and rigorously separate the actual bytes of the photo from the metadata that gives it meaning. Here's our roadmap for the explainer. We'll follow a single photo's journey, starting with the massive scaling problem, fixing the upload bottleneck, separating data from meaning, seeing why cryptography beats RPCs, optimizing at the edge, and finally, looking at the 5 operational questions you have to ask. All right, let's jump straight into section 1, the 5 million photo problem. Look, you literally cannot software engineer your way past the speed of light. A photon takes time to cross the ocean, and there's no getting around that. That is exactly why we use a content delivery network, or CDN. It's kind of like a chain of neighborhood convenience stores. When you want a soda, you just walk to the corner store, right? You don't drive all the way to a distant central warehouse. By having these edge nodes geographically super close to the user, the CDN saves massive amounts of bandwidth and time. So, when a celebrity tweet suddenly drives 50 million views, the CDN completely absorbs that spike, and your main server just sees a perfectly flat line. It's a total lifesaver. Okay, let's move on to section 2, fixing the upload bottleneck. So what actually happens when 600 users a second are all trying to upload 5 megabyte photos to your central API server? Complete and utter catastrophe. Look at these hidden costs. You're basically paying for double the bandwidth because the bytes have to come in from the user and then go immediately back out to storage. You are burning precious CPU cycles just for TLS termination. You're creating massive memory pressure, like 3 gigabytes just to buffer the data. Plus, you're holding connection slots open for every single user on a slow 4G connection. You are literally setting money on fire using your expensive servers as glorified network relays. But here is the internet scale solution, which completely bypasses your API server using pre-signed URLs. It's a 4-step dance. First, the user asks the image service to prepare an upload. Second, the service generates a short-lived cryptographically signed S3 URL. Third, the client uploads those heavy bytes directly to the storage bucket. And finally, S3 just verifies that signature locally. Notice what happened there? Your application tier never even touched the photo. This all boils down to a totally crucial engineering mantra. Your application servers should handle decisions, not data. By giving the client this secure cryptographic permission slip, we make absolutely sure the heavy bytes travel the shortest possible path to durable storage. And that keeps our API servers incredibly lightweight, fast, and most importantly, cheap to run. That brings us to section 3, separating bytes from meaning. So the bytes are now safely sitting in our S3 bucket. But honestly, they don't mean anything yet until the user actually publishes a post with a caption. Here's what our post's table schema looks like to give those bytes meaning. Check this out. We only store an image ID, which is just a random 130-bit string. We absolutely do not store the full S3 path or the CDN URL directly in the database. You might be wondering, why do we do it that way? Well, it's all about this golden rule: store identity, derive presentation. By only saving the image's core identity and then actively computing the full URL in your code when someone wants to read it, you unlock zero migration deploys. Seriously, if you ever need to change your CDN provider or maybe alter your S3 bucket layout, you don't have to go back and rewrite millions of database rows. You just update a few lines of code and boom, you're done. Now, once that post is securely saved in the database, we use a Kafka event bus to asynchronously notify all the other systems that care about it. The search indexer, the notification system that alerts your followers, your analytics warehouse, the trust and safety and moderation machine learning models, all of these just subscribe to the event independently. This keeps our main post service totally decoupled and blazing fast. Honestly, it doesn't even need to know those other services exist. Let's dive into Section 4, Cryptography beats synchronous RPCs. We absolutely have to talk about privacy here. Are private photos on these massive platforms actually private? Well, think about it. If you have a standard public URL for a private photo, anyone who gets their hands on that link can view it forever. And that is a huge privacy nightmare. This is exactly why we have to bind these URLs with a time bomb, like a strict expiry date and a cryptographic signature. The general pattern for doing this relies on what we see in JSON Web Tokens, or JWTs. This pattern is brilliant because it completely replaces the need for the CDN to constantly ping your backend authorization server just to ask, hey, does this specific user actually have permission to view this image? The real magic here is that the signature itself is the authorization. A JWT is basically broken down into 3 parts. You've got the header, which specifies the algorithm, the payload, which holds claims like who the user is and when the token expires, and the signature, which verifies the whole thing hasn't been tampered with. So the edge node just checks the math locally. If the math checks out, the request is valid. No slow backend call required whatsoever. This shifts your entire architecture in a massive way. Synchronous remote procedure calls are slow, they're expensive, they add like 50 milliseconds of latency, and they scale based on your very expensive origin server. But when you switch to cryptographic trust, it's stateless, it is blazing fast, and it scales infinitely with your CDN edge nodes. You literally eliminate 500 million expensive backend calls every single day. All right, moving into Section 5, optimizing at the edge. Okay, so we've got our files securely delivered. But if you serve the exact same massive 5 megabyte image to every single user across the globe, well, any senior engineer will tell you that's straight up malpractice. A user scrolling on a 5G iPhone Pro definitely needs that crisp 1080p image, but someone on a budget Android phone using a 3G network in a rural area, they just need a highly compressed 40 kilobyte JPEG. Instead of burning through their monthly data plan in 5 minutes, modern systems compute and cache the absolute perfect image variant dynamically, right there at the edge. Which brings us to our final section, the 5 operational questions. Before you go and ship this beautiful, highly optimized edge-first architecture to millions of users, you really need to drill this operational mental model into your head. For every single component you build, you have to be able to answer these 5 questions. How will this fail? How will we know it failed? How do we roll it back? What is the service level objective? And what is our true latency budget? If you can't answer all 5 of those right now, you are literally flying blind in production. To wrap this all up, if you take away only one single concept from this entire explainer, please let it be this incredibly powerful rule. At scale, cryptographic verification beats synchronous RPC. Put your trust in the math, rely on the signature, and push the actual heavy lifting as far out to the edge as you possibly can. So, I want you to take a hard look at your own systems today. Where are you currently wasting precious bandwidth, using your servers as glorified data relays? Where is your API doing heavy lifting that it absolutely shouldn't be? And how quickly can you replace those brittle, synchronous bottlenecks with blazing fast, stateless cryptographic trust? Thanks so much for tuning into this explainer, and keep building smarter systems.